Okay, now let's talk about water. Life, as we know it, wouldn't exist without water. Water in its liquid form, we can say it looks something like this. You've got the oxygen, big old oxygen molecule with the two hydrogens attached to it, and these are kind of moving around at their own pace. You know, they're vibrating around. While in a solid form, you see how they're kind of fixed. So water in solid form has a more crystalline structure. And you see there's more space between the molecules now. So we say the water is weird. Basically, water expands. It gets larger when it freezes and then contracts when it's heated. And this is strange. This is not what happens with all the other substances. And it has to do with this crystalline structure of the water. Now let's go back to the definition of density. Remember, density is mass per unit volume. So let's look at what happens here. You see, you've got in liquid form, water has more mass in the same area than solid um, or ice. So it turns out that ice is less dense than liquid water. Now, the solid form of water takes up more space than the liquid. It has more volume than the liquid, and so it is less dense. Now remember, things with less density will go to the top, which is why you wind up with ice on the top of your drink. Now, as the ice melts, the crystalline structure, that really nice little structure there, it collapses back down. It becomes more dense, and so the water goes to the bottom. Now, if I were to graph the volume versus temperature, it turns out that water is most dense at 4 Celsius. And then water starts acting like all other substances again with the L, or the change in length, or the actually change in area, is equal to the initial length alpha delta T. That's this nice coefficient of linear expansion that we did before. But with ice, it actually becomes less dense as you heat it. So this is kind of a strange characteristic of water that actually enables life on Earth to go on. So let's expand on that. Sorry. Suppose it's very cold out. All right, it's very cold, and it's, say, negative 10 Celsius. That cools the water molecules up here, and they freeze. It turns out ice is at 0 Celsius until all of the water is at 0 Celsius. Now, the more dense water, as soon as water hits 4 degrees, it becomes more dense and it sinks to the bottom. And the cooler water goes back up to the top until you wind up with water that is 4 degrees Celsius down here at the bottom. So in a pond or a lake, it is actually warmest on the bottom and coolest on the top, once we're close to freezing, that is. And this is also why you wind up with ice that gets thicker and thicker from the top down. Imagine what would happen if that wasn't the case. If ice were to sink to the bottom, what would happen? Then the lakes and the ponds would all freeze from the bottom up. So that by the end of winter, we would have just a whole bunch of dead fish lying around on top. It turns out this layer of ice actually provides protection to the wildlife that live underneath it. Kind of cool, huh?